We will move to our final presenter of the day, Dr. Darlene Cowart. Dr. Cowart is a corporate director for food safety and quality for Birdsong Peanuts, headquartered in Suffolk, Virginia. Her primary responsibility at Birdsong is the implementation and management of food safety and quality systems for all the regions that they operate in. She currently serves as chairman of the APRES Safety and Sanitation Committee, chairman of the Research Committee for the Peanut Institute. She is a board member of the Peanut Research Foundation, part of the American Peanut Council, and also a member of the the Peanut Standards Board, appointed by the U.S. Secretary of Agriculture. She received her biology degree from Presbyterian College and a master's and a PhD from the University of Georgia. And Darlene, you can take us to the house here.
All right, I hope you guys can see my screen. I hope you can see, hear me. And I'm really excited to be here today. What an amazing group of speakers that you've heard from already. And certainly just appreciate from an industry perspective, this team of experts and also the APRES group in full blown, everybody that's on here today for supporting the aflatoxin effort. I think it's something that's really important. Today I'm just going to give you an industry perspective, but actually I'm going to give you kind of a Darlene Scheller perspective. I do want to say that I'm chairman of the APSA Safety and Sanitation Committee. So the vice chairman, Courtney Dorsett from Premium Peanut, along with Lori Bunch from Golden Peanut and Tree Nut, Shane Powell, some others on the committee have certainly reviewed this, John Powell. So I'm going to walk you through something that I think all of us feel very passionate about, and as an industry perspective on aflatoxin. Let's see if I can make it move. All right, so what is aflatoxin? You've heard this over and over again today, but something that's really important for you to understand from our perspective, you know, it's a mycotoxin. It's obviously produced by a fungus, and we've talked about two that are very important, at least on the shell good side of peanuts, Aspergillus flavus and Aspergillus parasiticus. They are secondary fungal metabolites. There are 4 types that we have to test for within the sheller community. We test for B1, B2, G1, and G2. B1 is the most carcinogenic, and you've heard Patrick earlier today, you've heard different people talk about, in the US, we actually combine all 4 of those into a total aflatoxin number, and in the EU, we have to break out the B1 component at a much tighter specification at 2 parts per billion for B1 and 4 total. Fluorescence is used to detect aflatoxin. So again, it's a chemical compound. So it's not visually seen by the human eye. So it has to be detected with fluorescence. And it's a known carcinogen. So that's the reason that we have so much work done on it. That's the reason that we protect public health. And we try to do a really nice job within the industry of trying to manage aflatoxin. I think today what you've heard is more than manage aflatoxin and put up with it from now on. The goal would be to mitigate, eliminate, and try to do a much better job throughout the industry and being able to feed all these markets that really want our peanuts. And you've heard about how good peanuts are for you, so I think it's a really important process that we're going through. Just some history on aflatoxin. In 1960, in England, there was about 100,000 turkeys on a poultry farm that actually died, and they ended up calling that turkey X disease. I still have the original paper in my day timer from the turkey X disease. I just carry it with me kind of as a reminder of what it's like. You know, every day aflatoxin, we're dealing with it and how it got started. Once they started looking at why these turkeys died, they realized that it came from peanut meal from Brazil. So it came in on some feed. And obviously we continue to use meal and things like that to feed animals. And so it's very important that we manage aflatoxin, not just for human food, but also for animal feed. After they got to looking at it, they realized that whatever they were feeding, this peanut milk, was really highly toxic to poultry and the ducklings. And so this turkey X disease actually was found to come from, you know, a fungal origin. And you've already heard Dr. Brenneman talk about Aspergillus, you know, what that means. And so the way they found this, they said it came from Aspergillus flavus, and the toxin was given the name aflatoxin from its origin, A flavus or afla, and then the toxin that is made from it. So really, really, you know, important to manage this from a human and an animal feed standpoint. You've also heard people talk about today the predisposing factors, different things that occur out there. It can happen as far as seed varieties. We've talked about drought resistance. We've talked about seed not being treated properly in terms of, or we might have resistance to some of the seed treatments that we're putting on. So we know that seed can play an important role in getting the plant up, getting the really good, foliage out there, and basically developing the canopy that will hopefully protect our precious peanuts that we want to feed to all the world. High temperatures, obviously we've talked about soil temperatures, we talked about air temperatures, 72 to 95 degrees, around that 30 to 45 days before harvest. And I think that's really important. You heard Dr. Rowland talk about, early stress and late stress, and all those things are really important as predisposing factors in terms of high temperatures, and then drought conditions 30 to 45 days before harvest. And so we continue to monitor that all the time, and we're always looking at, Pam's newsletter coming out from UGA. I heard somebody mention that earlier today. So it's really important that we monitor these predisposing factors. Another thing that can happen is during harvest. You think about peanuts are typically planted, in square or rectangular fields, and the circles are circles. The irrigation is the circles. So you have these dryland corners in certain years, and if you commingle the dryland and irrigated acres, you can certainly cause a problem for aflatoxin. There are times during, you talk about the hurricane season, where we have short windows from digging and harvest, or we have rain at harvest. And so we end up with some high moisture kernels coming in. We also talk about foreign material for shellers. That's a real key, not just for aflatoxin, but also for meeting customer requirements on foreign material. But high moisture foreign material, if not removed, somehow during the harvest or cleaning process before warehousing, can also create these hot spots that will cause Aspergillus flavus to grow and then also to produce this toxin. Another phenomenon that we see in different parts of the country, some people mechanically dry, there are some field drying that goes on. And when you get into that, you can get uneven drying, and you can see single kernel moistures be very different across a range of numbers. And we always take the average moisture. And so the average moisture is 10.49% for it to be graded at the bind point for the farmer. But you can certainly have ranges around that are much higher in single kernel and cause some high moisture areas in the warehouse that can also cause aflatoxin. And then damaged kernels, we've already talked about, insect, mechanical damage, but we've talked about, damaged kernels can, in certain years, can certainly cause us some issues. And so you have to focus on those as well. Really important predisposing factors, and it starts with the seed and it goes all the way through the shelling plant in terms of just how we manage that and what we're trying to do, including, bind points, field work, farming, harvest, everything is involved. So you're always monitoring that. So it's really important to understand what those predisposing factors are. So how do we manage it today? It's a high risk. It's a high risk for shellers, and a lot of shellers today will monitor the crop during the season. Or you have some weather data that you get, so you know what's going on. You identify the risk within the crop or within the subregion of wherever you're monitoring the crop temperature and rainfall conditions. Then there's some regional testing done at harvest. You heard Dr. Rowland talk about, that we do have visual Aspergillus flavus mold is looked at by the USDA Federal State Inspection Service graders. But many shellers will take that further and they will do a chemical analysis. And I'm going to talk about that later. But basically, we know that, just because and Marshall said this as well, SEG3 does not always mean there's aflatoxin present. And the lack of a SEG3 or mold does not mean that aflatoxin is absent. So a lot of shellers will go out there and do some extra testing at harvest, and then they segregate their peanuts based on that risk that they find at harvest. And they'll have different levels for what they consider risk, depending on what they're trying to shell and how they're trying to meet their customer requirements and the country requirements that they're trying to ship to. Another thing we do focus on as an industry, I would say, is we try to focus on damaged kernels coming through our plants. We have electronic sorting. It also works on foreign material. It works on, damaged kernels. It works on discolored kernels. But the damaged kernels, if you can get those out, can sometimes help you with aflatoxin as well. And then every lot domestically that is made in the United States by shellers has to have finished lot aflatoxin testing. And that's done by a third-party lab. The sample is actually pulled in the shelling plant during the packaging of the 44,000-pound lot. And then the samples are sent off to a USDA or USDA approved lab for finished lot testing. So those are just some of the ways that we try to manage aflatoxin. Again, as Marshall's already clearly shown, 2019 has just been a really hard year, and some of these tricks just didn't work as we hoped it would. Just going back over the aflatoxin facts really quickly and then talk about the limits. Again, waste product from a mold. So it is, aflatoxin is not a mold. Aflatoxin is a chemical. The mold is what produces it. These molds, as Dr. Arias has just said, occurs naturally in soils, and they can be different depending on where you're at. Again, it's not visible, and it is a group 1 carcinogen that's been proven to cause cancer in humans. Now, here's the interesting thing. The USDA limit in peanuts, in shelled peanuts that leave our plants, the edible peanuts have to be at 15 parts per billion, and that's a total. Remember I told you there's 4 compounds, and so USDA limit is 15. The EU limit, again, once you pass the USDA testing, you have to do an EU test, and that is 2 more tests, and both of those tests have to pass at a 4 total and a 2B1. The interesting thing about this is you can pass all you want to over here, but then you ship it into the EU, and they have the ability to pull more peanut samples at the port off of your lot, and their samples can test above the 4 and 2, and then we're stuck with a lot in Europe that either has to be blanched or exported back to the US or sold as crushing stock, or maybe even some type of wildlife feed, depending on what the levels are. So again, the EU makes it very tough in terms of the amount of aflatoxin they'll accept in their country. Just a little bit on policy and testing history. Prior to 1960, we didn't really think there was a significant problem in peanuts. We really didn't know about it. Like I said, we found out about it through the turkey X disease. In 1965, FDA did establish specific guidelines for acceptable levels of aflatoxin in human food and feed. And then the Peanut Administrative Committee, which Marshall touched on earlier, which was this indemnification program, actually established the sampling plan and for the 15 PPB shelled lots. And the sampling plan was done by Dr. Whitaker and a few others at USDA in Raleigh. And today, that is still the best sampling plan in the world. And certainly it's gained a lot of notoriety in all the countries, and it is accepted by the EU as the sampling plan that meets their criteria. So really think we have the best samples we can get, and we'll talk about why that doesn't matter at some times in just a minute. In 1990, the Netherlands came out with the Dutch Code of Practice, where they wanted certain sampling and testing done on lots that came into the EU. And then in 1991, FDA actually developed and worked on methods for a different type of testing methodology, which is immunoaffinity columns and HPLC methods. And then in 1998, we finally got the EU established their maximum levels for aflatoxin. And I had this question asked me one time, and basically Codex establishes most of that, but each individual country can set their own levels, and the EU by far is the toughest. So just a quick chemistry class for those of you that miss it so much. In my organic chemistry class, we call that chicken wire, so you can see why that looks like chicken wire. But these are the 4 primary aflatoxins, B1, B2, and G1 and G2. The B's fluoresce in the blue color, and they're Aspergillus flavus. The G's are in the green color, and they fluoresce. I mean, they came from Aspergillus parasiticus. You also have some additional metabolic products that come out in milk or dairy if the meal or certain things are fed to cattle. Again, B1 is the most carcinogenic of the 4 that we deal with. So just thinking about misconceptions about aflatoxin, and I think Marshall really hit this really hard early on, and I just want to kind of reiterate what he said. Again, you've seen what I showed you earlier. Aspergillus flavus is a mold. It has the conidia. You saw Dr. Brenneman show it. And it is, that is how you get a SEG3. The farmers actually get a SEG3 if they find visible mold only. That's not a toxin. So when we say SEG3 peanuts are the only ones that contain aflatoxin, that's false. Aflatoxin, again, I told you, is not visible. It fluoresces. So any segregation can have it. Just because the mold is there doesn't mean there's aflatoxin, and in its absence does not mean that aflatoxin is absent. The US limit of 15 parts per billion should be easy to meet. That is also false, because the 15 parts per billion is the government limit, but many customers in the United States, as well as many countries and customers outside of this country, have specs that are well below the US limit, because keep in mind, their finished products on the shelf also have a limit. And so they're trying to get as low as they possibly can to make sure that they don't have an issue on shelf if FDA goes in or their country goes in, regulatory people, and actually start sampling on the shelf. So even though 15 ppb is our limit, it's really difficult to find someone that really wants a 15 parts per billion a day in and day out, just because of the nature of what they're trying to work on. Another thing is aflatoxin is homogeneous. That is so false. It can be one single kernel, and it's certainly not equally distributed throughout the lot. And what you'll find is we have in the US, we have 3 sample bags when we do the USDA aflatoxin testing. And we can test the first sample bag and get a 0. And once you get a 0 to an 8, then that lot is good to ship domestically. But we could take a 0 and send it in for the EU test. And you could have a 2, the second bag or the third bag, whenever it's tested, the 2 or 3 sample, it could be completely different. It could be 100, it could be 50, it could be 2 more zeros. But it is not homogeneous, and it certainly could be just one kernel, and it can really mess up really a load of peanuts when you think you've got it all together and you got one kernel that they find. So again, that's really important. Current reality for me, and Marshall showed some of this data earlier, since 1980, the industry on every year that ends in a 0, so this is 2020, has experienced aflatoxin crops at least one time in that 10-year period. So we're at 10%. Since 2010, if you remember, Marshall put up the JLA numbers, which I really appreciate that from our friends at JLA sharing that. But you could see, I would say we had 6 moderate to severe aflatoxin crops. And when I say that, it's above 10% failing on the USDA test. So we're at 60%. So as a scientist, the question you ask yourself is why? Like, what's different? Why now? What are we getting at? So we know our management systems and our sampling and testing programs have evolved over time. And I currently think it is one of the best in the world. So we're trying to do the things that we know to do, and we're also trying to do them routinely, and we're trying to be very diligent with it, and we're trying to learn every year. We try to learn, how can we get better? How can we get better? But when we go from 10% every 10 years to 60%, something has changed. And the question is, what's changed in the past 10 years to cause such an increase in aflatoxin in peanuts? And the questions that we've got to answer that question as a group. And so some of our thoughts around next steps was, what role does genomics play in aflatoxin? We know that the industry is currently funding some projects in this area through the American Peanut Council. And we also know, talking to Dr. Arias, and you've seen some other work we sat in on the Peanut Innovation Lab work the other day. There's a lot of work going on this. So how do we get all of us to play together in that genomic space to understand what's available to us? What about a drought-tolerant peanut that really can yield? Can you get that from the genomics? How do we find that kind of stuff? So I think that's a really interesting play that we have to work on. What about climate fluctuations and its impact on the prevalence of A. flavus as well as drought? Has this changed in the last 10 years, and why? So what are we seeing from a climate standpoint, and what are we seeing from a mold standpoint that might be causing us some issues there? How do we measure aflatoxin throughout the supply chain to assure food safety? What role does the farmer play? What role does the buying point? On and on and on. It's a supply chain issue. And I thought Dr. Rowland's talk was extremely timely and very excited about seeing that, because I think we do have to own this together, and we have to all get into it together, because it's not just the sheller, and it's not just the manufacturer, and it's not just the grower. You can see it had a seed impact. It certainly has an issue with FDA. If it's on the shelf, it has an issue with the shellers and trying to remill or blanch. It's an industry problem, and I think we have to look at it that way as a supply chain approach. What impacts will the continued aflatoxin crops have on domestic and export markets? Can we still participate even in the tighter markets? And I know that's been some questions I heard asked and answered earlier today as well. And then how as an industry can we come together for the common good of peanuts and public health to make sure that we deliver the very best, safest product that has the most nutrition, as Samara talked about earlier, and it's affordable, it's sustainable, and it's nutritious. And we need to make sure that it's also very safe. And so with that, I just implore all of us as a group to continue to fight together and to come together and work together and figure this out, to Marshall's point, so that we can win in the end, because I don't think it's going away. And we've got a lot of smart people in this industry that have a lot of good work going on. So we need to rally the troops, and we need to take care of aflatoxin. And so with that, I say thank you, and I appreciate your attention today. And thanks to all people at APRES for putting this on. Thank you for inviting me.
Okay, Darlene, we have a question that says, are other crops seeing an increase in aflatoxin? Have you heard anything about that?
You know, it's interesting you asked me that because some of the guys that we purchased some of these test kits from when we're doing testing at the buying point, they typically talk about that, and I have heard them talk about that corn has seen an uptick in it. I'm not sure about cotton, but you know, it'll depend on the. But I think the corn industry is certainly seeing an increase in it as well.
Okay, well, great. For Darlene, we have a question that says, is aflatoxin found more often when semi-drying trailers are used?
So we don't have any exact data on that, but I can tell you that you know, when we have some buying points that use semi-trailers, we have some that use the small wagons still. But what we see is it's much more environmental in terms of either pre-harvest aflatoxin contamination or post-harvest. And when we look at the drying, I know Dr. Butch has done a lot of work on that. I mean, we think the drying through mechanical drying gets the most even drying. I think it'd be more of a field drying situation where you'd have multiple seeds in there that might be higher moisture kernels. So it's certainly something we have not looked at it from an aflatoxin standpoint, but what we see is it's more of environmental conditions either in the field or during the field after they're dug up.
Okay. Another question for you would be what is the post-harvest handling on the aflatoxin content of peanuts? I think maybe she's talking about how do you go about cleaning those up?
Oh, yeah. So certainly after we shell the peanuts and we fail the USDA grade our aflatoxin certificate, it comes back above 50 parts per billion. We have a couple of options that are given to us under the grade standards, and we can certainly either remill the peanuts, where we can try to take out more damage or try to get out the kernels that are a little bit smaller or immature, or we can blanch them and remove the skins. Blanching is still considered a raw peanut, but once you remove the skins, Dr. Tom Whitaker did a work, about 90% reduction in aflatoxin on peanuts, you know, when you remove the skin. So blanching or remilling are only two options. The only other thing we can do is go to oil stock with them, crushing.
Okay. Question. We'll go out with a doozy here. I think it's for Darlene. If gene editing could be used to reduce aflatoxin, would the industry accept this as a method?
Oh, that's a great question. And I think it's something that we've talked about many times as the genomics project went on. We talked about, you know, GMO versus non-GMO. I think the question would be, how does our consumers, and particularly the European Union, accept gene editing? I think, you know, I think they've been very clear they don't want GMO. I know that here in the U.S., gene editing has been, you know, kind of talked around with the Secretary of Agriculture. But I know it would be an important tool from a research standpoint. I think that's what the industry has kind of taken on. Let's use it for research for sure. But we do have a real hard stop with it in the EU as far as I remember and know about. So I think it would just depend on the consumers and what they would take, and also, you know, are these regulations in these other countries.
Okay. I just had one more question pop up. I think we're getting down towards the end. I think this may be for you, Darlene. The other problem is that the visual test cannot distinguish between toxigenic and atoxigenic farmer stock grading system.
Well, if they're talking about on the, yeah, I mean, certainly if they're talking about, you know, the Aflagard, I know that was some questions early on because it looks, it's an Aspergillus fungi, and so you're going to see some of that. So yeah, certainly in our world, you can't tell when you're looking at the mold unless, because the conidia look very similar. So it's very hard to tell if it's going to be a toxin producer or not.
Okay. Well, great. Again, I want to thank all the speakers. I think we've reached the end of our questions, and we wanted to get all those questions in because we are recording this session so people can look back at it later if they had to leave for some reason. I think we've had an excellent day. I know I've learned a lot. I think both the morning and this afternoon session were very, very informative. I think we have a few housekeeping things that Dr. Tillman wants to go over just maybe about tomorrow and how things are going to work. So if he is still on here, I'll let him speak up, and then we will close out for the day.